Hi guys, if you have questions, email me or write a comment.
Hi again. Today I'm going to talk about the antiderivative. From its name, we're going to find the opposite of the derivative. So for example, if I have f prime of x equals 4x cubed. Question is, if this is the derivative, what was the original function f of x? Probably all of you will say x to the power of 4, since the derivative of x to the power of 4 gives you 4x cubed. What about x to the power of 4 plus 2? Well, that will also give you 4x cubed. What about x to the power of 4 minus 7? Same thing. Okay, good. What if the derivative was f prime of x equals 3x squared? What was the original function, the antiderivative? The antiderivative here was x cubed, or x cubed plus any number. That's great. In general, instead of keep writing it this way, we can write it as integration of f prime depending on x will equal, or will give you, the original function plus a constant. So if I say integration of 3x squared depending on x, you would say now it's equal to x cubed plus any constant, and that constant will be called the constant of integration. This is the integration. Well, how would that be written in general? Instead of keep writing the derivative and original function, simply we can say integration of any function depending on x will be equal to capital F of x plus c. Why did I use capital F of x? Because I wrote here f of x, not f prime of x. But what does that mean? This means that the derivative of f capital is equal to what's inside the integration, small f of x. So, for example, if I said integration of f of x depending on x is equal, for example, to x to the power of 4 plus sine x. Find small f of x. What should you ask yourself? Well, you should say small f of x is the derivative of this thing, and this is capital F of x. So simply, small f of x will be equal to the derivative of capital F of x. Small f of x equals derivative of capital F of x. Again, small f of x is equal to derivative of capital F of x. So immediately, this will be equal to the derivative of x to the power 4 plus sine x. That's an addition, so derivative of each one alone, 4x cubed. Derivative of sine is equal to cosine the angle times derivative of the angle. So 4x cubed plus cosine x. I think this is easy to understand. So integration in general means the antiderivative, and that's our title, antiderivative and indefinite integral. So this is called an indefinite integral. Later on we'll talk about definite integral and you'll figure out what's the difference. Okay, let's try to generalize this. How can I find capital F of x easily? Am I gonna always guess? Of course not. Let's have a look at this. 4x cubed, the original was x to the power 4. 3x squared, the original was x cubed. So simply, we just add 1 to the power. But Is it only like this? What if this function was x cubed only, or this function was x squared only? What does that mean? How would I find the rule? Let's think about it. Let's say that I have x cubed only. X cubed is a derivative of what? For sure, it was a derivative of x to the power of 4, but actually when you derive x to the power of 4, you should get 4x cubed, not only x cubed. So where did the 4 go? To get rid of the 4, simply you just need to divide by 4. So integration of x to the power of 4 should be x to the power of 4 divided by the 4. Check that out. What's the derivative of x to the power of 4 over 4? Derivative of x to the power of 4 is 4x cubed divided by 4, so the 4 with 4 will be cancelled. So when you have x cubed, you will just make it x to the power of 4 divided by 4. It's the opposite of the derivative. When you use to derive, you use to multiply by the power. In this case, what should you do? You will divide by the new power. This is actually the first rule of integration. If you want to integrate anything to the power of n, x to the power of n, not anything. If you want to integrate x to the power of n, that will immediately be equal to x to the power of n plus 1. So you will add 1 to the power, and don't forget to divide by the new power. And of course, there is always a possibility of constant c. So for example, if I said find the following integrations, let's say that I have integration of x to the power of 5 depending on x. What would that be equal to? You would just apply the rule. You just add 1 to the power, divide by the new power, plus a constant c. How can I check? Simply, this is capital F of x. You need to derive it to get small f of x. So check that out. F prime of x is equal to 6x to the power of 5 divided by 6 plus derivative of any constant is 0. Now 6 with 6 will be cancelled, so this is only x to the power of 5, and that was your small f of x. So this works for powers. Let's see if I have integration of x to the power of negative 5. What would that be equal to? Would that change anything? Actually, no. Same thing. X to the power of negative 5 plus 1, that's negative 4, divided by the new power, which is negative 4 plus a constant c. You can check that by deriving, of course. What about integration of square root of x? Well, how am I going to do this? That's not even a power. So what should you do? First of all, you need to rewrite this in the term of x to the power of half, depending on x. Now you have a power. So how are you going to integrate this? Same thing, x to the power of half plus 1, so it's 3 over 2 over the new power, 3 over 2 plus c. Of course, you can rewrite this as x to the power of 3 under square root divided by 3 times 2 plus c, multiplied by the conjugate. Well, that sounds good. Okay, what if I have integration of a constant only? What should you ask yourself? A constant is a derivative of what? For example, if I said integration of 5 depending on x, what was the original function? What was the original function? So it was 5x plus c, since the derivative of 5x gives you 5. So in general, if you are trying to integrate a constant alone, that will immediately give you the constant times x plus c. Good. What about this example? Integration of 3 dt. 3 depending on t. Well, it's the same as derivative. Here the variable is t, so that will give you 3t plus c. Integration is as simple as that, and I'm going to continue later on with other rules and properties of integration.
Remember to like, share, and subscribe, and write your questions via email or comments.